A very warm welcome to track 4 this morning. So the people here in the room and everyone at home in front of the computer. My name is Philipp Schmid. I will be the host for today on track 4. And I'm really excited. We have an unbelievable, a really amazing and exciting lineup in track 4. We cover many topics, from data labeling, noisy data, missing data, services, smart services, fintech, and true value in data. So let's jump directly to our first speaker. Our first speaker, Owen, he will cover the topic we all know. We have usually plenty of data, but not enough labels. And to create label is usually quite expensive. So Sean will present an active learning approach with Modal to overcome this issue. Sean is a principal solution architect at Databricks. He is an Apache Spark Committee, PMC member, and a co-authored Advanced Analytics with Spark. Previously, he was a director of data science at Cloudera and an engineer at Google. So let's give him on the stage a warm welcome here on virtual video. Sean.
Well, hello, everyone. This is Sean Owen, and I'm a principal solutions architect at Databricks. Today, I want to talk to you about an interesting technique and a library that implements it. The technique is active learning, and the library is Modal. Now, I should say, number one, I'm apologies, I can't do this live because of the time differences. I'm in the middle of the United States. And also, even though this is from Databricks, this won't be about Databricks. This won't be about Spark per se. It's something you can really, ideas you can apply just about anywhere you like. So don't worry about that. So what are we talking about today? Well, I think we can all agree machine learning, generally speaking, is amazing. It can do some amazing things, like almost pretty much convince us that it knows how to drive. If you can do style transfer, you can think of the advances in GANs. There's just a lot of incredible things that machine learning can do. And maybe some less incredible things, but still interesting nonetheless. It's fascinating that today we can build an image classifier that can recognize hot dogs versus not hot dogs. And yes, this is a reference for the Silicon Valley show fans. But if there's one thing tricks like this really need, it's data. It's not easy you can't really just feed images to this black box and have it learn what hot dogs are. You need the data, you need the inputs, yes. But we also need to understand, we need to tell these processes, in the case of supervised learning, what the correct answers are for some definition of correct. We need outputs, we need labels. And I think this kind of reveals the dirty secret about a lot of the power of these thinking machines with artificial intelligence. A lot of these techniques do cool things, but they're really more parrots than oracles. They are learning from a bunch of examples, and they have to be fed those examples in order to do what they do. They can't just figure it out from scratch. And so this is a problem. It's difficult at times to even have good, clean, large amounts of data. But in the case where we are trying to apply machine learning to learn to do something intelligent, often we need to pre-decide what the right answers are for some large subset of that data in order to then apply the machine learning. And of course, that's the whole thing we wanted in the first place. We wanted some process that would label the data for us, but we're building that process off of labeled data. There's a catch-22 here. Now, in some cases, like you might imagine, building a model of customer churn. Is this customer, based on their attributes, going to stop using the service within the next week or so? Well, you're going to know the ground truth of that within a week or so. And a lot of times, we can collect the right answer from observing the world. But in some cases, we can't. For example, as you'll see here, let's say we wanted to build a text classifier that might evaluate a certain sentiment in text. Unless we can happily find some pre-trained model, someone's trained on their own data set, or a big, rich set of labeled data that just happens to match our problem, we're going to have to label some data. And labeling data is kind of a pain because it often requires humans, and humans are slow. Humans are expensive, and they can even make mistakes as well. Maybe humans don't even necessarily know what the correct answer is in all cases. So that's where a set of ideas commonly known as active learning comes in. And I want to show you a worked example applying these ideas through a Python library called Modal to a data set from the Consumer Finance Protection Bureau in the United States. So the data set I'll show you in the example has a bunch of complaints recorded by this Consumer Protection Bureau in the United States. You can submit complaints with a lot of information, including a free text field describing your complaint. And if you've ever worked in customer service or support, I'm sure that some of this text, it looks a bit familiar to you. It's redacted here, but you can see that some of these seem pretty normal and some people seem a little bit angry. So maybe we want to proactively classify these tweets according to whether they seem distressed, whether the person seems like they'd be raising their voice on a call. Now, if we knew that ahead of time, but we had those labels, this would be easy. It's just a text classification problem, but we don't. And there's 440,000 of these data points. And I don't know about you, I don't feel like labeling all 440,000 of them. And it's probably true that if I labeled 10,000, 20, 30,000 of them, I might get a pretty good model. And I may not need to label all of it. It's just that I don't really know how many, and I don't know which of these examples is most useful to label. So that's where a tool called Modal and the idea of active learning comes in. Modal is a Python library that pretty much helps you decide what instances, what inputs would be most useful to label to improve the performance of a classifier or a regressor that you're training. So the learning becomes active in the sense that, well, where humans are in the loop already, to label data, you don't start by labeling all the data. You label some, create your model, go learn what other data is most useful to label and label that, and then try again and repeat until you've got a good enough model. And hopefully that's done well before you had to label most of the data set. It helps minimize the amount of manual expensive work that may need to go into labeling. To give a sense of what Modal is trying to do, imagine we've trained a classifier. It's trying to differentiate two classes, class 1 and 2. That's blue and red here. And I don't know, we can train a simple logistic regression or support machine on, logistic regression here. And in this case, we know the labels for some of the data points, the ones that are blue and red. And it looks like the classifier does a pretty good job. The shading here shows what regions of the input the classifier thinks are very likely to be blue, class 1, or red, class 2. And all the other data points that are black are not labeled. And if we wanted to improve the performance of this classifier, we'd like more labeled data. But we want to be smart about that choice. And so you might think, which of these points would you like to know the label most for if you were the classifier? Well, it's probably not the ones at the top left or bottom right. Those are in regions that are clearly strongly probable to be within one class. It's probably these points in the middle where it's quite uncertain what the right label is. These would be very interesting to know to help figure out where this decision boundary really is. Are these really mostly blue or are these mostly red? So Modal is, for a number of definitions like this, going to help you evaluate that on the on input as according to some classifier that you're trying to develop over time. So let's jump over to a demo where I can show you some of this in action and maybe along the way, show you some other interesting tools you might want to use with Modal, like Spark as well. So briefly, I'll skip through here. We install Modal. It's a simple Python library. Read the raw data. And there's a lot of columns here, but we're just going to be interested in this one free text field here. Let me pull that out here. And this is what I showed you earlier. We've got IDs, we've got the free text here, and we're going to build a text classifier, but only after we have some labels to train the classifier on. So we might build an initial model here. As I say, there was no way around it. To start, I had to go label a couple hundred of these instances by hand. So I tried to decide whether I figured the customer sounded distressed or something and put that all in a spreadsheet and imported that here. A pretty low-tech solution, but for this, it's fine. So with a couple hundred data points of labeled data, yeah, we can go ahead and build a model here. So here we go. We've got our labeled data now. And in this example, we'll use Spark to do some of the pre-processing like tokenization. You don't have to. It's actually a pretty small data set. But we'll reuse this later when we have to do the same thing to a much larger original data set. So it's nice to have this in Spark for scale. And so we featureize the data. These are simple TF-IDF vectors representing the text. And we'll do the most simple thing we can think of, just train a logistic regression model on top of it. You're just using scikit just to build this classifier. The key thing is logistic regression, of course, can give us a probability estimate out, and that will be very important to helping us decide what is most useful to label next. So you train the model, and I've actually also thrown in here an example of hyperopt. So we're using hyperopt to even tune the model, so we can pretty easily pick the best penalty and regularization here for this model. And I'm actually using MLflow too here, just to illustrate for those that may be interested what MLflow does. Adding it to this training process means that when I run it, I get some nice results out of my hyperparameter tuning and my final model. And just if we're interested to see what that looks like, I end up with, actually, I think I've got it here, yeah. After doing my hyperparameter sweep here, and here's some other results of that, I get my nice model ready to go and logged in a pretty organized way and ready to go reload and evaluate with Modal. Okay, so we've gotten our initial model, and it's not going to be necessarily that good, but we can go ahead and evaluate it. We've done a test train split here, of course, so we can evaluate this model that hyperopt is tuning. And the bad news is the accuracy is only about 62%. So that's not much, it's not much better than random. But hey, we just only had 100, 200 data points out of a data set of 440,000 possible inputs. So maybe we just need a little more labeled data. And maybe I'd like to just label 100 or 200 more, not a couple thousand. So this is where Modal comes in. For all that setup, using Modal itself is pretty simple. This is really all you do. For a basic setup in Modal, one of the key classes is called Active Learner. And an Active Learner needs the model you're interested in evaluating and all of the data you want to evaluate on. So I'm going to go ahead and throw it everything we know about this data set. We actually have a bunch of input here and some labels here too. And this will help it understand the model itself. But we then want to go back and apply this learner that understands how the model's thinking about the input to a whole bunch of other data. We still have almost 440,000 other data points from which we're going to choose maybe 100, 200 more to go label by hand. And to do that, you can apply Modal directly. It's this query method here. We give it some inputs. We don't know the outputs. We give it the inputs here and a number of instances, a number of candidates we want it to choose for us to go label. Now, because this data set's big, I went ahead and showed how you could wrap all this up in a UDF. So we're working in pandas here, but then we're going to use Spark to apply this function to all the data we have in parallel so we can go faster. Even 440,000 is not that big, but hey, this at least this shows that if you needed to choose from a pool of 1 billion instances, you could do it this way with Spark, and it wouldn't be any different than applying Modal to a couple hundred data points. So we go figure out what Modal thinks is most useful to label here and return those. And what we get back out is simply another data set, another set of complaints that we would want to go label by hand. And we, before we do that, I actually went and ran those instances back through the model. And indeed, what we get here tells us that on all of these instances, the probability it's predicting of being this distressed positive class is just about 50%. So it has indeed chosen instances where the classifier is very uncertain. And you may be wondering so far, well, yeah, how are we defining what's most useful to label? Well, in the case of a binary classification like this, it's pretty trivial. It's what you'd imagine. You are looking for instances where the probability is close to 50%. And frankly, you could do that without Modal. We could all implement that as a pretty straightforward piece of code. But as I'll get to in a moment, Modal does include a lot more definitions of what's good to return, what's useful to label, that you could use to get different answers, non-trivial answers in less trivial cases like multi-class classification or in a regression setting. Before we go here, I actually took a second to try and visualize what Modal is doing. And I think this picture is easier to see here. So I've used PCA to project these document vectors down to a 2D space, and then used it to highlight from this sampled set where the positive and negative classes are, they're blue and green, and which of the points Modal wanted to know the label of. And it's a little hard to interpret, I admit, but it looks like it is picking points that seem to be in regions where there's a mix of labels, not from regions where the labels are pretty uniform. So maybe that makes sense. Maybe that gives some intuition about what it's doing in this case. Before I go back and talk about what else Modal can do, what happens if we then go back and label this data, sure, and throw it into the model? Well, we end up with about 70% accuracy here. And okay, that's better. For labeling just a couple hundred more data points, I got a lot of value for my effort here. So this, I think, illustrates how a little bit of code can help your human-assisted training loop pretty easily. The last thing I'll mention in passing is that you can apply Modal, as I say, with Spark, maybe to a stream of data. So if you want to pick up in real time which things that your model is uncertain about to kick out for evaluation, to become part of your training set, you can do that in real time as a stream as well. But I want to return briefly to talk a little bit more about the things I didn't show you about Modal in this case, just in the interest of time. Number one, you can choose different definitions of uncertainty for its uncertainty sampling, for picking out which instances are worth labeling because they're uncertain. The one we were using was simple uncertainty sampling. The question there is, possibly in a multi-class classification context, which inputs yield the highest class probability that is farthest from one? So instances where the most certain class is pretty uncertain. So if I'm classifying over 10 classes and the most likely one is still only 60% likely, that's kind of uncertain. Maybe that's one that I want to evaluate regardless of what the other classifications were. Margin sampling, this picks cases where the most likely class is not much more likely than the second most likely class. So there's not much margin between its actual vote and the runner-up in its classification. Maybe that's a better definition. And lastly, you can pick these based on entropy, which of the class probability distributions have the highest entropy or uncertainty. And you can see that you can think of these are class probabilities in a three-way classification. And these plots from the Modal documentation show you qualitatively how their choices are different from each other. For ensembles, there's also different definitions based on what the different ensemble members are predicting. So we could look at the votes and add them up and figure out which inputs gave votes with the highest entropy, that were most mixed and kind of even rather than certain towards one class. Maybe if we average the class probabilities out of each of the ensemble members and look at the entropy of that's consensus sampling, that would give us a different definition. And lastly, we might look at ensembles where the individual ensemble members produce class distributions that are the most different from their average, from their agreement, from their consensus. And again, those give qualitatively different choices here from these samplers about what points in the space are useful to look at next. It keeps going from there. There's a lot more interesting stuff inside Modal. For example, we didn't talk about regressors, only classifiers here, but there's equivalents for regression. For example, active learner becomes this Bayesian optimizer. Similar ideas, but it's a different, it's a Gaussian process underneath. Disagreement sampling, things like that also exist for regression. They're just defined differently, like in terms of standard deviations of the predictions rather than the class distributions. You can choose based on the density of the input in certain regions. You can, as I mentioned, do stream-based sampling. And if any of this is intriguing, I would just encourage you to go take a look at the docs for Modal. The documentation is good and comprehensive, and there's some great examples there. And it really is pretty easy to use. With that, thank you very much. I hope this was interesting. I hope it gave you an idea of something you might want to try if you ever have to go label data and you don't want to label at all. If you like this talk, I did write it up as a blog post previously along with the notebook that I've just shown you. So if you're interested, you can follow this link and see all the details offline. Thank you.
So, a very inspiring talk, really hands-on, so I think you should give the Modal library a try.